Yes, I'm audible.
Yes, sir.
Yes, let me start. And next topic is Maxwell relation. Yes, explain Maxwell relations.
Sorry, sir.
Maxwell relations. What the main application of Maxwell relation in thermodynamics?
Maxwell relation. So Maxwell relations are mainly used to derive the relation between the various thermodynamics variables.
Yes.
So there are mainly four Maxwell relations which we can uh, which yes
Yes, carry on.
yes sir. SVT and so if we start with the first Maxwell relation, it is curly T upon curly P at constant S is equal to curly V upon curly S at constant P. So this is the first Maxwell relation. The second Maxwell relation is the first Maxwell relation, and another Maxwell relation is curly S upon curly V at constant temperature will be equal to curly P upon curly T at constant volume. This is the another Maxwell relation. Sir, third one is the curly V upon curly T at constant P will be equal to VTP will be equal to SPT. This is the next Maxwell relation, and the last Maxwell relation is curly P PT V will be equal to ये तो yes so SV second, third, and the last Maxwell relation is P S at V will be equal to TVS minus sign. So these are the four Maxwell relations, sir.
Yes, what is the main purpose of these relations in thermodynamics?
Sir, these relations are used to interrelate various thermodynamics parameters. Like if we have to relate entropy entropy with volume and temperature, or then we can use Maxwell relation. So to interconvert one parameter to another parameter, we can use Maxwell relations.
Yes, Maxwell relation is del G is equal to VDP minus SDT. Yes.
Yes, sir. One
Yes,
Maxwell is yes, sir.
yes.
Del G is
How
equal
to,
to
yes. How to
VDP
drive
minus.
of this formula?
So how to drive this formula?
Yes.
Mm, sorry, sir, I don't know its derivation.
And next del H, del A, del E. Yes, how to drive, any idea?
del H, del A, del U. Sir, these can be determined directly from the Maxwell square. So, like, sir, del H will be equal to TdS plus VdP. Del A will be equal to minus K PdV minus SDT, and del U will be equal to TdS minus K PdV.
Yes. Any drawback of these relations?
Drawback.
Yes.
No, sir, I don't know any drawbacks of this relation of these relations.
Any limitation?
No, sir, I don't know.
Any uses? What are the uses of Maxwell relation in thermodynamics and our real life and our society, human life?
Yes, sir. So the main uses of Maxwell relation is the interconversion of the various thermodynamics parameters, and also, sir, if we talk about the real life, then the process will be feasible if delta G is less than 0, or these variables such as del H, del A, del U at particular parameters. For example, uh, del G at P and T, if it is less than 0, then only the process will be irreversible or feasible. If it is equal to 0, then the process will be at equilibrium. So if for any process at particular, if we keep the pressure and temperature constant, and for that process the value of delta G is less than 0, then that process will be irreversible, or that process is feasible.
Yes. Good. What is Joule-Thomson effect and Joule-Thomson coefficient? Explain. What the difference?
Yes, sir. So, sir, Joule-Thomson effect is that if we change the pressure, or if a substance is made to expand from a region of high pressure to a region of low pressure, then there will be cooling in that cooling in that substance. So the change in temperature with change in pressure at constant enthalpy will be minus 1 upon Cp. So this is the major relation of the Joule-Thomson effect, sir. It is an isoenthalpic effect, and Joule-Thomson coefficient is equal to change in temperature with change in pressure at constant enthalpy. If the value of Joule-Thomson coefficient is greater than 0, then there will be cooling, and if value of Joule-Thomson coefficient is less than 0, then there will be heating.
Yes, Joule-Thomson coefficient. Yes, ideal gas mu GT is equal to 0 always. Yes. What the region?
Yes, sir. For ideal gas.
Ideal gas mu GT always 0. Why?
because sir, for ideal gas there are no intermolecular interaction which are taking place. Or we can say that sir, like if mu jet is equal to 0, so B will be equal to 2A by RT. So at this temperature, sir, at this condition, the intermolecular forces will not exist, or there will be no intermolecular interactions in the ideal gas, and for that the value of delta H upon delta T at constant pressure is 0. If we use this value in the Joule-Thomson equation, we get mu T curly T upon curly P at constant at H equal to 0.
Yes, and real gas, mu jet is equal to positive. And
Yes, sir.
yes, why? What the reason?
If we talk in terms of mathematics, mathematical expression, we can say that for real gas, the value of according to second law of thermodynamics, the value of curly H upon curly T at constant pressure will be less than 0. Or we can say that, and we can say that, sir, the for ideal gas there will be intermolecular attractions, so there will be corresponding change in the pressure and also in the volume. So all such condition will lead to the result that for ideal gas mu jet is positive. If mu jet is positive, then sir there will be cooling effect.
Is if pressure is high, then mu jet value is
If pressure is high,
yes.
1 second, sir. So if we can change it in the form is equal to minus 1 by Ct plus Pv on curly T at constant pressure
Yes, pressure is high, so mu jet value is negative. Yes, no.
Yes, sir. If
What is inversion temperature?
negative, yes sir, yes sir.
What is inversion temperature?
Yes sir. So yes. From this equation we can also conclude the same, sir. If pressure is high, value of mu jet will be negative. And sir, inversion temperature is that temperature at which the effect of Joule-Thomson, at which the Joule-Thomson effect will take place. So if the temperature is like, sir, this is the Joule-Thomson equation. If the temperature is above inversion temperature, final temperature is above inversion temperature, then TF minus TI will be greater than 0, or Joule-Thomson coefficient will be negative and there will be heating. And if the inversion final temperature is less than inversion temperature, then TF minus TI will be less than 0 and μJT will be positive and cooling. So inversion temperature is the temperature above and below which heating and cooling starts. And if the temperature is equal to inversion temperature, then there will be no heating or cooling.
Yes. What the uses of inversion temperature in thermodynamics?
Uses of inversion. So inversion temperature can be used in those industries in which liquefaction of gases are required. For example, if there is any specific industry like petrochemical industry or any other industry where we need to liquefy the gas, the concept of inversion temperature will be beneficial for such industries.
Yes. What is Boltzmann equation in thermodynamics? Boltzmann entropy equation.
What is
Boltzmann entropy.
Boltzmann entropy? Yes, sir. Yes. So it is equal to S is equal to KL and W. K is Boltzmann constant and W is the thermodynamic probability. And so this equation is also a link between the statical thermodynamics and classical thermodynamics. It acts as a bridge between classical thermodynamics and statistical thermodynamics.
Statical thermodynamics or classical thermodynamics? What's the difference?
S is equal to. Sir, the major difference is that, sir, classical thermodynamics deals at macroscopic level, and statical thermodynamics majorly deals at microscopic level. So the value of variables, according to classical thermodynamics, we can calculate the change in the value of variables like del U, del H, but but to calculate the absolute value of such variables, we need to look into statical thermodynamics. So if we need the absolute value of the internal energy or entropy or enthalpy, then for absolute value, statical thermodynamics is required, and for the change, classical thermodynamics can be used.
Yes. And what is Carnot cycle? Carnot cycle.
Yes.
The main application of Carnot cycle.
So Carnot cycle is used in Carnot engine. Carnot engine is a perfect engine So the main application is that, sir, the Carnot engine has the maximum efficiency. So if we make any other engine for comparing its efficiency, Carnot engine is used. So to compare the efficiency between the engines, or how much the engine, how much efficient is any particular engine, Carnot engine is used, sir.
Yes, Carnot PB graph a slope and TS graph. What's the difference of these one?
Sir, the major difference is that, sir, in PV graph, the variables are pressure and volume, and that graph will be a curved graph. But if we then in this graph, we obtain straight lines, not curves. So if this is the first process, second, third, and fourth, straight lines. The variables are temperature and entropy in TS, and pressure and volume in PV.
Yes. What are the uses of these one?
Sir, the main use is that, as I had already told you, that, sir, if there is any other engine, and we need to find out how much efficient is that engine, then the efficiency of that particular engine is compared with the Carnot engine. If its efficiency is less than Carnot engine, then it will be an irreversible engine.
Yes. Any drawback of Carnot cycle?
Major drawback is that, sir, Carnot cycle is a theoretical cycle, and in actual practice, Carnot cycle is not possible. It is a theoretical model only.
Vertical. Any uses in our society? 2-3 point.
That engine which is used for that particular vehicle is compared with the Carnot engine. If the efficiency is very much less than the Carnot engine, then there can be then we can make certain improvements in that particular engine to improve its efficiency. Also in the refrigeration, sir, the process opposite to the cycle, if we change the direction of the cycle of Carnot engine, then that process will that process is heat pump.
Yes.
So the opposite cycle of Carnot is, yes, opposite cycle of Carnot is also used in in making refrigerators, and the direct Carnot engine is used to compare the efficiency of any engine which is required for the motion of the vehicle.
Yes, good. What is Gibbs free energy? Gibbs free energy.
So Gibbs free energy is represented by delta T delta S. It also so to determine the feasibility of any process, the concept of Gibbs free energy can be used, and to determine its non-mechanical non-PV work, then also the concept of Gibbs free energy is used.
What is Gibbs Helmholtz equation? Gibbs Helmholtz.
Yes, sir.
Okay.
So
What
Gibbs Helmholtz equation is delta G minus T Yes, this is the Gibbs Helmholtz equation, sir.
Yes.
This is the Gibbs Helmholtz equation, sir.
What the difference
Delta
between
G is equal to delta
and what is work function, Helmholtz function, Helmholtz free energy function? Do you have any idea?
work function is represented by A, sir. If A is equal to U minus Ts, or delta is equal to delta U minus T delta S. This is the work function, sir. Work function is the maximum work. The decrease in the work function is the maximum work that can be done by the system. It includes both PV and non-PV and other types of work. This is the equation for the work function, sir. Del A is equal to del U minus T delta S.
Yes. The last point, and what a drawback and limitation of thermodynamics.
Drawback and limitation of thermodynamics.
Yes.
So one drawback is that, sir, thermodynamics only deals with the thermal parts, thermal part. So whether the process is kinetically feasible or not, or how much time a particular process will take. This is not given by the thermodynamics. Or thermodynamics doesn't give any information about the rate, sir. So this is the major limitation of thermodynamics.
Yes, what the beneficial of thermodynamics in our real life, a human society, human being?
Yes, sir. So in real life, sir, thermodynamics is visible to us. We can say that thermodynamics is visible to us everywhere, from heating, cooling, refrigeration. All such processes are examples of thermodynamics, sir. How the heat transfer from one place to another place or one body to another body takes place, if there is heating in the substance, cooling in the substance, boiling, condensation, evaporation, all such are uses of thermodynamics.
Yes, good. The next move on, next new topic is chemical equilibrium. Let's explain. What the main application of chemical
Yes, sir.
equilibrium?
Yes, sir. So equilibrium is a state in which two opposite forces balance each other. So if two opposite forces balances each other, then that state will be equilibrium state. And if we talk about chemical equilibrium, then if the reactants and products are are in equilibrium with each other, or we can say that the forward reaction and the backward reaction are same, rate of forward reaction and rate of backward reaction are same, then that process is known to be in chemical equilibrium.
Yes, what the difference between chemical equilibrium and ionic equilibrium? What the difference?
Yes, sir. So in chemical equilibrium, we have particular reactants and products, but in the case of ionic equilibrium, we have the equilibrium exists between between an unionized ion, for example, let's say Ha, and its constituent ions. But in case of chemical equilibrium, there are specific reactants and specific products which have different constituents. But in case of ionic equilibrium, the equilibrium exists between an unionized ion and its constituent ions. Or we can say that, sir, in ionic equilibrium, a particular compound and its derivatives are used. But in chemical equilibrium, we have different compounds.
Yes, how many stage present in equilibrium condition in chemical equilibrium? Any example?
Equilibrium reaction.
Yes, like water. Example is water. Yes, how many H present in water?
Hmm. So if we have two molecules of water, then there will be equilibrium will exist between the S3O positive and OH negative ions, sir. Stages about.
Yes. What the difference between static and dynamic equilibrium?
Yes, sir. So dynamic equilibrium is that equilibrium in which the reactions are taking place, but the rate of forward reaction and rate of backward reaction is same. But in the static equilibrium, there will be no reactions. The reactions are completely stopped. So this is the major difference between static equilibrium and ionic equilibrium, sir. For example, if we hang a weight over a pulley, and for that particular equilibrium, that equilibrium will be static equilibrium. And sir, in chemical processes, the equilibrium is dynamic equilibrium, because at every point the reactions are taking place, but the rate of the forward reaction is equal to rate of the backward reaction. So it appears to us that the reaction has stopped, but actually the reaction hasn't stopped, but the two opposite rates are equal.
Yes. What is a law of chemical equilibrium and equilibrium constant? What the difference between chemical equilibrium and equilibrium constant?
Yes, sir. So law of chemical equilibrium state that the rate of chemical reaction is directly proportional to the product of molar concentration of the reactants. Each raised to the power equal to its stoichiometric coefficient. And so in equilibrium, for the equilibrium constant, let us say we have an process, then its equilibrium constant will be equal to, so this is how we can calculate equilibrium constant, sir. Equilibrium constant is the ratio of concentration of product to the concentration of reactants.
Yes, good. यस, अभी इतना पार्ट हो गया है. अब कल हम आपको लेफ्ट पार्ट ऑफ केमिकल
Yes, sir.
इक्विलिब्रियम डिस्कस करेंगे. उसके बाद आपका नेक्स्ट टॉपिक जो होगा वो नया और
Okay,
करेंगे.
sir.
तो कल दो टॉपिक कल कर लेंगे, है ना.
Okay, sir. Okay, sir.
फिजिकल स्पेक्ट्रा है ना आपका, ओएमसी कोऑर्डिनेशन. यस, कल